Hey class, welcome to section 9.2. Today we are going to talk about measuring angles and arcs within circles. So we're going to start off with our first vocab word of the section, and it's called a central angle. A central angle is an angle with a vertex at the center, and the sides are the radii of the circle, or radius of the circle. So if you notice here we have a circle, we might call this part X, that would be our center, and then this angle right here, angle 1, would be considered a central angle. And notice, because X is the center, these two sides here, maybe XY and XP, are going to be each a radius of this particular circle. All right, so central angles at the center. Pretty easy way to remember it. One key thing you want to make sure you know is that central angles always add up to 360 degrees. So in this particular picture right here, I have three different central angles, and notice that because they all are side by side like this, I can add them all up and they're going to equal 360. So I'd say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, all of those are going to equal 360. So we've kind of done problems similar to this when we were working with triangles, how the angles in a triangle added up to 180. Now we're doing something similar. We're just going to be adding angles to add up to 360 since we're dealing with circles. Right? So here's our first example using this concept. It says solve for x. So notice we've got a circle here. We have four different central angles, and they want us to find the measure of this particular angle. So because we know central angles can be added together, and we know all of these together are going to equal 360, we can just make an equation. So we'd say 85 plus 40 plus, even though there's not a measure here, we know that's 90, and then plus our missing angle, central angle x. Together, these all have to equal 360. And so now you can just go ahead and start to solve. So adding 85 plus 40 plus 90, that's going to get us 215, plus x equals 360. And then we can go ahead and subtract 215 to both sides, making sure to be careful with our solving. And we get x is equal to 145, and then we'd be done. So as long as they are all together going to go all the way around a circle, then we can make them equal to 360. So you want to be careful of that. All right, next vocab word is an arc. An arc is just a portion of a circle. So there are basically three types of arcs that we're going to be looking at, but the arc, if I were going to draw this in, might look something like this. So in this particular picture, the arc is going to be this part of the circle. All right, so it's along the outside edge. It's no longer an angle anymore, okay? It's part of the curve around the circle. So the three types of arcs that we have here, there are minor arcs, major arcs, and then semicircles. Minor arcs are always going to be less than 180 degrees. Major arcs will be greater than 180, and then semicircles, which are probably going to be the easiest, those are exactly 180 degrees, so you can think of those as a half circle. All right, and when we name arcs, we use the letters that are on the circle. Okay, so we want to use any letters that are around the edges, nothing that's in the center. Okay, so only letters on the outside. So for example, this particular arc that I had drawn up at the top, this would be considered a minor arc because it's less than half. Okay, so it's less than 180. So to name it, I would call that arc, and then I put the letters A, B. So notice I have this little arc symbol that goes across the top. Now if I wanted to name a major arc in this picture, okay, maybe I put another letter here, the major arc that I'd be working with would be this round, or this red one all around the outside edge here, and I might name that as arc AC B. So notice I go in order of the letters so I know which direction to go. If I said ABC, I'd be going around another direction and that'd be a completely different arc. Okay, so order matters when you're naming the letters, so just be very aware of that. And here are just examples. And again, we can show you, maybe this is X and this is Y. Okay, so arc XY would be considered a minor arc, and maybe arc XCY would be considered a major. And then here, if I wanted to name a semicircle, then I could say arc AB, or maybe even name it arc ATB. So it depends on the letters that you're given, but we can tell hopefully the major differences between semicircles, minor and major. So let's look at this example 2. It says segment GJ is a diameter of the circle K, and it says identify the arcs as minor, major, or a semicircle, and then you need to find the measure. So one thing that's really important about arcs is that their measurement is the same as the central angle. So that's something you might want to write down if you don't have down already. So the arc measure equals the central angle. So in part A, it says find the measure of arc GH. So I would always go ahead and make sure you know which arc you're working with by maybe marking it on your picture, highlighting it, whatever you need. So arc GH, in this case, remember if we know, we have to look at our 3 options, minor, major, or semicircle. Well, this arc is less than half of the circle, so this is going to be a minor arc. So we just have to write minor. And then to find its measure, we just have to look at the central angle that creates it. So the central angle that creates it is going to be angle GKH. Notice that my angle opens up to create these 2 endpoints. Okay, so and started at H, ended at G. So my measure is going to be 122 degrees. Done. Okay, so sometimes there's not a lot of work. You just have to look at the picture. Part 2 or part B of this says find the measure of arc GLH. So here we want to follow the letters around. Okay, so starting at G to L all the way to H. Now notice I never went inside the circle because an arc goes around the outside. Okay, so I'm looking at this outside edge I just marked in green. Well, notice this arc is over half the circle, so this is going to be a major arc. And in order to find its measure, we have to know a couple things. They don't give us any degrees right here, so we might have to fill in what we know. Well, we know that this part of the circle is half, so we know that this right here is 180 degrees. Okay, and then we can also figure out what this measurement is here by just doing some simple subtraction. So you could do it one of 2 ways. You could take 180 minus 122, because these 2 angles here add up to 180, or you could take 360 minus all of these. Okay, so 360 minus 122 and minus 180, that's going to get you 58 degrees. Okay, so I just did some simple subtraction. If you have any questions about where those numbers came from, please make sure you ask. Okay, but now I want to know what these measures are, so I can just add these 2 things together. So 180 plus 58, if we add those together, we get 238 degrees. Which makes sense because remember we said that major arcs have to be bigger than 180 and 238 is, so it would be good to go. Okay, so really that's all you have to know about measures. Just know that they're equal to the central angle, and you just need to be able to identify if they're major or minor and naming them. Now, central angles and arcs are actually really helpful if you're ever going to be looking at data. So in this case, we've got a circle graph with percentages of female participation in different sports, and they want us to find the measure of each of these particular arcs. So we'll start with A. So it says the measure of angles or of arc CD. So arc CD right here is volleyball. So notice that they give us a percentage of the female or the women that participate in these sports. But we want to find the actual measure, not a percent. So we have to think about this is a percentage of a whole. Okay, so if I'm looking for this degree, then I need to figure out what percentage this is of the whole circle. So remember 18%, okay, can be written as a decimal as 0.18. We just move the decimal to the left twice, okay, or divide by 100. So this is the 18%, and I'm going to multiply that. So I'm going to take 0.18 times the total number of degrees we can have in a circle. Well, that's 360. So now what this is saying is what is 18% of 360? So I can take 360 times 0.18, and that's going to get me 64.8 degrees. And this should match up with the size roughly of your piece of the chart, because if you notice, 64.8 would be considered a minor arc because it's less than 180, and that definitely is, so then we're good to go. So I want you guys to go ahead and try finding the measure of arc EF. So notice EF is for soccer. Okay, so you need to convert your percentage into a decimal and then multiply it by 360, and that should get you the degree. So go ahead and try that and then type in your answer. All right, the next vocab word that we'll need to know are adjacent arcs. The word adjacent is not new. We talked about that lots last semester. All these are arcs in a circle that have one common endpoint. So in other words, these arcs are side by side. It's the best way to describe it. So in this particular problem, I have a couple adjacent arcs. I could say that arc AB is adjacent to arc BC. Okay, so notice AB, arc AB, is next to arc BC. They share one endpoint, and that is B. Okay, so they don't share A, they don't share C, they only share the middle endpoint here. And if I can use this to help us find different measures. So maybe I told you the whole measure of arc AC, you could use that to figure out what the measure of BC is. Okay, so we kind of did this already a little bit, but just so you know the vocab if you ever see this, adjacent arcs are arcs that are side by side. Last thing that we want to talk about is the arc length formula. Now, arc length is different than arc measure, and this is very important that you know the difference between the two. So an arc length is the distance between the endpoints along the circle. So I've got this nice picture here that I would definitely draw in your notes. Notice arc length, we use a cursive L to represent. Okay, so the arc length is talking about the actual distance from one part of the arc all the way across to the other, not the degree. Okay, so it's a portion of the circumference. So because it's a part of the whole circumference, we're going to actually be setting up a proportion, which is kind of nice. So when you're asked to find the arc length, you are going to be talking about a couple things. You're going to have the degree of the angle. So the degree is going to be a part of the whole circle, which is 360. So degree over 360 is going to be equal to, we just said that arc length is a part of the circumference. So the arc length, L, is going to be a part of circumference. Well, what is the formula for circumference? 2 pi r. Or depending on what you're given, you could use pi d. Okay, most of the time we'll have radius, just depends on the picture. So this proportion right here, you want to make sure you write down. So this is the degree, and this is the arc length that you will typically be solving for, and then this is circumference. Okay. And 360 will always be the same because that's the total number of degrees. So let's just go through an example of this together and then we should be good to go. So it says find the arc length of arc AB. So we've got a random circle with an arc in it. If the diameter is 6 centimeters, so that's important, and the measure of arc AB is 45 degrees. So a couple things we want to look here. So they gave us the degree, so we're going to go ahead and fill that into our formula. So we'd have 45 degrees over 360 equals, we don't know the arc length, we're looking for that, so L, over, and then we need our formula. So remember, circumference is equal to 2 pi r. So if the diameter is 6, then we can say our radius is 3. So we'd have 2 times pi times 3. Or you could also just do pi times diameter, so you could have just had 6 pi here. It's the same thing. And now we just have to simplify. So when you do these problems, you're going to be cross-multiplying because we've done proportions before. Hopefully that's familiar. So we'd have 45 times 6 pi. I'm going to leave pi in my answer to start. So I'm going to get 270 pi equals 360 L. And then I'm going to go ahead and divide. So 270 divided by 360, that's going to get us 3/4. So dividing by 360. Notice I'm leaving pi in my answer. They'll ask you to probably round at the end. So I'm going to cancel out my zeros. 9 goes into both of these, so we get 3/4 pi equals L. And then, of course, if you want to get the decimal answer, you just need to multiply that 3/4 by pi in your calculator, which is going to get you that the arc length is roughly 2.36. And in this case, we're talking about centimeters, I believe it was. Okay. Now notice that when we're talking about arc length, we have units at the end. So you want to make sure that with arc length, you include whatever units they give you, or if they don't include units, you put the word units. Whereas with measure, we're always in degrees. Okay, so there's a big difference in the labels and how we find them. So measure is always equal to the angle. Arc length, you have to use your proportion. Okay, so if you have any questions about how we solve for this, make sure you ask me. these are really good examples to go through, and you're going to see quite a few examples of them as we continue through this semester. Okay, that's it for this section. So if you have questions, make sure you are ready to ask in class. Thanks for listening.